From the home studio, sorting out the problems today. This is the 5th time I've tried this problem, but here we go. Example problem 213. At a point in a structural member subjected to plane stress, there are normal and shearing stresses on the horizontal and vertical planes through the point. I'm going to start sketching that stuff out, and if you look very carefully, you can see the lines on the piece of paper below. Oh my goodness, that job is terrible. Because I've already done this a couple times, and most of the video is going to match up with the other stuff. But there's my little stress cube. I drew it big because I want this stuff to be legible. And it will or won't be. I put units on and I put units off. These are all in units of stress. So we can put 6 KSI and 8 KSI, or we could leave it off. But I also have a shear stress. I also have a shear stress of 4 KSI. 6 KSI compression, 8 KSI in tension, and you know I like writing that stuff down. I got to put a coordinate system on, and that's really about as far as I've ever gotten with this first video. Y direction. There's my X direction. Make that a little more clear. And then I'm going to write those things down over here. Sigma X is equal to 8 KSI. Sigma Y is equal to minus 6 KSI. And I've got my shear XY, get my mug out of the way, shear in the XY direction is equal to a positive 4. That's on the positive face in the positive direction, so that's a positive 4 KSI. Now our task is to find sigma P1, sigma P2, and tau max. We also have an additional task of looking at where those stresses are at a 45-degree angle, and we'll jump into that at the end. But this provides us a good starting point and a good segue into the next video. So there you go, into the next portion of this video. So let's start solving that. So we're going to go to our directions that I'm pulling up from the previous page, and that's what I showed in the lecture. So the first thing is, it says choose a set of XY reference axes. They're meaning this. Where's my axis so that I can get these labels? All right. And then we're going to identify the stresses and write them down with the proper sign. That's step 2. That's step 2. So now we're going to draw, now we're on step 3, we're going to draw a set of sigma n and negative tau nt. What we're drawing is a set of coordinates, an XY plane, right? And normally I would say this is the x-axis, but this isn't. In this case, this is the sigma n axis, and this is the tau axis. It's not sigma n axis either. We're going to have that later. It's the sigma axis and the tau axis. All right? And then it says with sigma n and tau nt positive to the right and upward respectively. So this is positive and this is positive. Then plot the point sigma x and negative tau. Okay, so sigma x, here's my first point. And if I put sigma x, that's going to be equal to 8, and negative tau is going to be equal to negative 4. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. Yeah, you know, that's about twice that, so that's my first point, and that's going to be x. That's my point x. And then I'm going to plot, actually they're saying don't label it x, label it v. That's on my vertical face. That's actually, this is my stress on the vertical. It's in the x direction. Yep, we're starting, all this language is important. Then we're going to plot, so I'm going to label this as a step. This was step 4. Then we're going to do step 5. which is to plot sigma y and positive tau xy. All right, what's that? Sigma y is -6 and 4. So -6, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Okay. So that's there. -6, 4. This is 8, -4. Label this. This is my horizontal face, or it's my y face. Okay. Now draw. Okay, plot that. Draw a line though between those, and that establishes the center. So I'm reaching over into my desk drawer to grab a straight edge. I guess that's my Kelvin ID from 2015. It's a faculty ID. Actually, it's probably older than that. Whatever. Now you know my code, my employee ID. Actually, that's my student number too. All right, I did this amazingly well, and the reason is we want to know what this y-intersect is. Well, let's go on. Step 6 was draw the line. This establishes the center. Think about that. I've got this triangle and this triangle. From 8, this crossed at 1, so this distance is 7, and this distance is 7, and this distance is 4, and this distance is 4, -4, but 4. So, I mean, I really did a good job, even with the chicken scratches, to get that to cross at 1, and that's now the center of my circle. Now, I know what my radius is. That's my center. My radius is right there. So, I draw something like that. Okay, that's a bad circle. And we'll see how bad later, or we'll see how good later. I don't know. Could be. This point, this isn't right, but that's okay. What's my radius here? Well, I don't even have to look at equation sheets or anything else. I should have loaded them up. My radius is equal to the square root of 4 squared plus 7 squared equals, and I'm going to look in the book for the answer because I didn't bring my phone over here to run the calculator. So that's 8. 8.06 is what the book answer is. So that would mean if this is 1, then this would cross here, not here, but it's going to cross here at this point, which is 1 plus the radius 8.06 equals 9.06. And that's, this whole circle is the, as I rotate around, those are all the possible combinations of normal stress and shear stress. So this stress here, that is sigma principal 1 right there. And this point back here, that's going to be 1 minus 8 is going to get me to just past 7. Well, this was 6. So if 7 is right there, that's going to get me to sigma P2 is equal to minus 7.06. I'll start boxing these answers because they're showing up. My radius is key. What's my maximum shear stress? What's my maximum shear stress? Tau max is equal to, well, that's just the radius because that's it. So that's the radius, which is equal to the 8.06. How's that? Now, I don't, KSI. I should have units everywhere. I should have a box around this. A little bit of cleanup on my stuff. Does that all make sense? Well, here's the part of this that's really cool is I think if you can start to envision this, this stuff does make sense, and we can go back and put our equations out there and really work through this. I wish I had my equations loaded that I could just flip them up on the screen. I don't, so I'm flipping through the book to go back and getting my maximum stresses, which I got to go back in the book all the way to, yeah, I'm just stalling for time, just stalling. The principal stress, the principal or the maximum shear stress is equal to plus or minus, this is equation 217, the square root of sigma x minus sigma y divided by 2, quantity squared, plus the shear squared, right? That's my equation. Now, let's look at that. This distance from here out to here, this where I got this 7, that's going to be equal to really the difference between these 2 points, which was the 8 minus the negative 6, and then I divide that by 2. That's how I got to the 7 in one sense. That's just graphical. So this is 8 minus the negative 6 is 14, divided by 2 is 7. So that gave me my horizontal run, and then my rise was just my shear, and the sign doesn't matter because I square both of those things, and that's how I got my radius. That's this, that's that there. That makes sense to me. And I've worked a lot, I know I've worked a lot of these problems. It can be a little confusing. So once I've got my radius, well, I need to know where my center point is. Well, my center point always has, it's always at 0 for P1 and P2. I know that. And then the other things, those are going to be, the center is going to be at the average of those two. So if you go back to this, if you go back to your other equation, sigma P1 or sigma P2 is equal to x plus y divided by 2 plus or minus the square root of, remember all that stuff, but this was just the radius, which was given above. This defines the center point. That defines the center point. Okay, let's start it again. Let's do it again. Oh, I'm going to pause because I don't have another piece of paper. Well, maybe I got paper sitting here. Nope, I don't have paper sitting here. Hold on. So while I was grabbing paper, I talked to my son for a little bit, and he promised me he would be yelling downstairs as much as he can at his Xbox. So we got that going for us. I wanted to go back. I want to do this again, and I want to do it from scratch now that you've seen it once and don't understand it because it was quick. I want to go through it again, and we'll label this out. So I'm going to start smaller because I want to make my circle bigger. So I have this little stress square, and I've got a coordinate system here, y and x, and I'm going to put my forces on here. This is compression of 6, this is tension of 8, and this is shear of 4, and I'm going to write that out. Sigma x is equal to 8, sigma y is equal to minus 6, and the shear xy is equal to 4. Now we'll see if I can draw the circle as well as I did last time, but I'm going to put a coordinate system, and actually I'm just going to put this line, and I guess because I never know where to put the 0, but I do. I'm kind of evenly balanced, so it's 1, 2, 3, 4, 5, 6, 7, 8 there, and then I got to go 4 down, and 1, 2, 3, 4 up, and 6, 3, 4, 5, 6. So this is minus 6. That's plus 8. This is minus 4, that's plus 4. Now, this point here is going to be at 8 minus 4. It's at, and that's one of the tricks is for that X face, that face in the X direction or the vertical face, you have to plot the negative shear. You don't. So it's 8, -4 there, and then -6 and 4. And I'll tell you, I know, and my ID can't bridge the gap. Let me see if I got something else here quick. Oh, look at that, a ruler. Look at that, a ruler. Look at that. Scientists can, there you go. Scientists can be astronauts, discover dinosaurs, study nutrition. Anyway, from that point to that point, and it goes pretty close to right through 1. And these points are just defined as that this is the point representing the vertical face, which is the X face, is equal to 8, -4. The horizontal face is equal to a -6, +4. So you can see the center of the circle is equal to, or is at 1, 0, but that's equal to sigma x minus sigma y divided by 2. Sorry, sigma x minus sigma y divided by 2. And that, again, sigma x, sorry, plus. See, I was catching that. Sigma x plus, it's right here. It's right there. That's the center of the circle. And then you can get the radius just by saying, well, this distance, I can look at this. I know that's 7, I know that's 4. Well, that distance is the difference between those divided by 2 and shear, which is what we had over here for this equation. The difference divided by 2 squared plus that squared, the shear squared, square root. That's how we make, and we can, so I think this is cool. I can also say, look, I know that radius equals 4 squared plus 7 squared. It hasn't changed. It's still 8.06. So this is going to cross here. Here's 9. And this circle is going to go like, whoop, right there. And it's going to go 6. No, it's going to go 7 plus a little. So it's going to go right there. There. And my radius is 8. So realistically, 5, 6, 7, 8. It's going to be right. It's got to go through that point, and it's got to go through 5, 6, 7, 8. It's got to go through this point. Now I can start getting a better circle. Okay, I really can't get a better circle. I still draw like a left-handed orangutan. There's my circle. Now, that got us to this point. Here's my maximum. That point defines my maximum. This is my x-axis, really. And this, the confusing part, is my y-axis. Why is that? Well, because all my angles are in 2 theta. That's also why I wanted to draw this better. All my angles are in 2 theta because that's the way we got to this set of equations. And so if I look and say, this is my maximum, this is P1, and I want to know where it occurs, well, the angle that occurs is 4/7 is going to give me the tangent. So tangent of, and I told you this was 2 theta, so I got to write tangent of 2 theta is equal to 4/7. Now, you should start to be seeing these numbers a little bit. You should start to see where they're coming from. 4, that's my shear stress. That's my tau xy. What does the 7 represent? What does the 7 represent? Well, it's sigma x minus sigma y. Sorry, sigma x minus sigma y divided by 2. And now if we go back and look at our equations, you're going to see, I don't have the equation number. I want to tell you the equation number, because I'm sure you've got the study guide in front of you where I'm just flipping through the book. Equation 214 looks like this. Tangent of 2 theta is equal to 2 times the shear stress divided by sigma x minus sigma y. Look, did we derive that? Yeah, we kind of did. Yeah, I mean, that's where that 7 comes from. It's this average, or it's this, you subtract those two and divide it by 2, and that's how you get to the middle point. And this is our run, and this is our rise. And this is just reorganized. So, hey, that is a winner equation. And now we know where the maximum stresses are occurring. We just have to calculate that. That's where this Mohr circle stuff's kind of cool. I can look at, so if I go back to a big picture, if I go back to this and I say, hey, how do I get to the principal stresses? Where are my principal stresses are going to occur? Well, I don't know what that angle is exactly. I mean, I could calculate it, but I do know that if that's my x, that's my n, oh, and that's my t. That should be farther that way. That's a sloppy drawing, but I know that n is going to be up by exactly half of what this is up. Now, that again is a challenging because we've got a coordinate transformation. This looks like, and in your mind is always the x-axis, and it's not. This is the x. I labeled it. I'm going to get, let's see, what's my favorite color here? Oh, this is a nice blue. I do like the blue. But now I can't show it. That's my x-axis. So this is up from x to the n-axis. All right? We didn't do the last part of the problem. We didn't do the last part of the problem, which was to find the stresses on an arbitrary plane AA. It was find sigma n and tau n on a plane with theta equal to 45 degrees. But that's just use the equations. I mean, it would be really hard to go here and say, okay, 45 degrees. Oh, no, actually, maybe it's not. 45 degrees from here is going to be 90 degrees here. So it's going to look like that, right? And realistically, that's going to take this from 4, 7. It's going to take this to 1, 2, 3, 4, and then 7 up to that point. So I know what that point is. Now, okay, there's my guess. There's my guess. That's what I'm going to tell you. And now we've got one more thing. That would give me stresses. So sigma and the normal would be 4 plus 1. So that would be 5 KSI. And my distance has to be 7 up, so that's my shear. So shear N is equal to 7 KSI. Now, the next thing I want to do is show you how to check those things. And I have to change my TV technology, change my recording technology to get to the next system. So hold on a sec. I got to start, and then I'll stop. I'll be back. Be back in a sec. You won't even notice. So what you're seeing is my screen where I went to a site called aimsweb.info. I should show you the beginning. Oh, I can't click on it there. I should show you the first screen. Oh, maybe I can't show you that. Oh, yeah, I can. There are a ton of calculators and stuff. Advanced Mechanical Engineering Solutions. And we will visit this in 305, and we will visit this again in machine design, because they do some really good calculators. They're not rocket science. I mean, we did all of this stuff, but they've just put it into a JavaScript so that it runs anywhere. So I can go and grab, they have, I'm going to scroll down and show you what they've got so you don't grab the wrong one and get confused. They have a whole section on stress and strain analysis. So this is for chapter 2 and chapter 3 of Riley, what we're doing. And they have Mohr circle for 3D stress analysis. If you go back to our problem, and I think I can turn it on. There. No, can't turn it on. Hey, wait. If you go back to our problem, one of the assumptions that we made, it's behind. You can't see it. Oh man, never mind. It's one of the assumptions we made was that we were working with a plane situation. So we don't want the 3D solver. We want to move to. We don't want 3D. We want to move down here. Plane stress calculation. Oh no, not with strain rosettes. No. How about no principal stresses and strain? No, we don't want that. Plane strain calculator range. Oh man, I had it a second ago. Plane stress and strain, plane stress and transformation with Mohr circle. Boom. And that's what it is. Plane stress transformation with Mohr circle. Now, we go down here and they say, look, here's your problem, and this is what we're going to give you. So what are your input parameters? Well, just that little chart that I made up at the top of the other page. My normal stress in the x direction was equal to 8. And my normal stress in the y direction, I have to get my sign right, is -6. My shear stress was 4. My transformation angle, because they're going to take the information that I give them and they're going to run it through some rotation and then come back with an answer. Well, the angle that I'm dealing with, if you look at the problem statement, is 45. So, hey, throw in 45. Now, is that the angle from x to n? Yes, it is. Okay, so 45. In a positive clockwise? Yeah, okay. Hit the calculate button, see what happens. Nothing. Well, actually it did. They gave me results down here. What did I have? I had 5 for my normal stress. What are they giving me? 5. My normal stress in the y direction, I didn't calculate that. We could have done that too. That's not magic. That's 5. My shear stress was 7. They've got -7. Oh yeah, that makes sense too. Let's talk about that. Let's talk about why I screwed up. Let's do it with the big picture, and let's see if I can turn on that camera, document camera. Zoom. And I turned it on, but it went to the back, so now I got to put this to the back. Remove order, move it to the bottom. If this is up here, remember I'm plotting negative shear. So this is actually a negative. If I were going to plot that, that would be -7. It would be whatever that point is, 5, -7. And I forgot the negative. Sign error, do it all the time. It's your job to catch it. I hope some of you are watching the video going, no, Tubergen, don't do it, it's wrong. No, yeah, I know. Okay. Yep, there you go. Okay? That's Mohr circle. That's Mohr circle. Now, what's really kind of interesting is let's jump ahead. Let's jump ahead and say, hey, let's do problem 2. Still got my ruler in the page, so that's good. Let's do problem 214, not 213. So ignore that stuff in the upper page. 214, and they give me a at a point in a structure subjected to plane stress, subjected to horizontal and vertical stuff. Well, they give me this. They give me this picture, and I'm going to redraw it. 36, 72, 24, Let's write this stuff down. Sigma x is 72. I'm swapping to black because I think it shows up better. Sigma y is equal to positive 36. Shear is equal to a negative 24. All right? I can already envision the circle. I can already envision the circle. See, the center of these is at 54. And the difference is 18. So what I've got is a circle that looks like the radius is equal to the square root of 18 squared plus 24 squared. I can already see that circle. And then I'm going to say, oh, and they want to know, what the, they're just asking to start out with, find P1 and P2. So if I go back to my calculator, okay, so I want to go back to my calculator, so I'm going to turn off my document camera, and that pops right back up. And then I go over there after the transformation. I got to put in the new values. So the normal stress was 72. The normal stress in the Y is 36 minus 24. Did you notice I didn't put units on my problem because it could be an MPI or KSI or PSI or. They're units of stress. That the software wants you to pick something. It doesn't matter. Oh, I was supposed to find my principles. I'm supposed to find my principal stresses, and all this is doing is a plane stress transformation. That's let me go my principal and maximum shear stress calculator. Let's pull this one up. This is going to be a little bit different. I'm going to filling in the same things. This is 72. This is 36. This is minus 24. And I hit calculate, and does it have answers for me? Yep. And they're showing me a picture. They're showing me a picture. If I had drawn that, right, what I said was the center point would be at 54, 0. Why? Because that's the average of those two. And then this gives me plus 18 and minus 18. Oh, sorry, that's it's plus 18 to here. And then I have to go minus 24. So if I go 18 and I go 24, so I've got to go like this. That's 18. And this is 24. And this is 18, and that's 24. And so now that's going to look like this. And my first point, my vertical is at 72, comma 24. That's because it's negative, it's 24. It's negative the shear. So that's that point. And that is what you're seeing. See, I got too many things going. I was drawing on my, oh man, that's confusing. I was drawing out my Mohr circle. I knew the center. I could put those lines in. This is 18 to here, so I knew that this was 3 lengths, and this was 4 lengths, right? Because it's, if you divide by 6, it's a ratio 4 to 3 for that triangle. All right. And now that's my vertical axis. And so this now, that's not 2 theta. I have to go around clockwise to go all the way around to get to 2 theta. So that's negative 2 theta. Right? And if that's 4/3, it's just more than 45 degrees. Let's say it's like 55 degrees, right? Well, you know what? They'll tell us. The code will tell us. So let me turn off the document camera, jump back to this, and then we'll start scrolling. Sorry. This is 55 or 60 degrees, right? But that's 2 theta, so theta is actually, I'm going to say it's like 27, 30 degrees. Well, if you're looking at the screen, you probably noticed it's 27. It's a negative 26 degrees. And that makes sense with what? It makes sense. Makes sense with what we're doing. If we went back to the other code, to that other page, and I put in an angle, said my transformation angle is minus 26.6. I don't remember. Close enough. Close enough. Scroll down. My maximum stress is 84. That's this point out here. 84. And my, well, I calculate the radius. I know what it is. It's 30. It goes from 54 to 84. So that means this goes from 54 to 24. And it's 30 tall. And my x-axis, if I'm drawing coordinate systems, it's way over here, right? This is 54, that's 24. Here's where 0 is. This whole Mohr's circle, the whole problem is in tension. It's being pulled on every direction. All right? I hope that between that really short lecture, which is probably confusing because you just have to play with this stuff, and this, we're in kind of good shape, but it's something you got to play with. So, for the homework, do these. There's 3 homework problems, 87, 88, 89, best of my memory. Do those using the tools and making your own bad pictures, okay? Same quality that these are. And check them out using Ames Web or another solver. There are a lot of solvers on internet. And check your answer. I guess you could check your answer by Chegg. I don't use it. Anyway, I hope you're doing well. And this episode was sponsored by Samsung SD cards. They are the SD card of champions. Have a great day.